I got two questions. Probably the same type questions, I don't know. This one is question 17.
Yeah, I got that wrong.
And this one is question 19. So it's 17 and 19. Chances are they're probably those word problems.
Mm-hmm.
And like I told you, on the word problems, you just ignore the words and you find the two numbers. So what are the two numbers here? 48 and what? 72? So they're going to want one of those two, the greatest common divisor or the least common multiple. Now see, today I have forgotten which one's which. I for some reason, I just can't remember that. Anyway, so here's 48 and 72. And I'm going to use my 2, 3, 5, 7, 11, and sometimes 13. What? This is the first question that was sent to me. I don't think this was yours. Okay, so what will go into 48 and 72? 2. So that'll be a 24 and a 36. 2, 12, 18. 2, 6, 9. 3, 2, and 3. And at that point, the real math what? Real math stops. So this is your, which one is it? First one. What's the first one called?
LCM.
Thank you. So the LCM is equal to 8 times 3, which is what? 24. So now I'm going to finish, and I'm going to divide by 2, and that'll be a 1, and that 3 will come down. And then 3, that 1 will come down, because you can't divide it, and that's a 1. We've got our 1s. So this is your greatest common divisor. Things are really getting on my nerves. So our greatest common divisor, 24 times 6, is going to be a 4. 144, somebody check me. What's 24 times 6? I may have it wrong. 24 times 6, somebody tell me.
144.
Okay. So one of those two numbers is your answer. Probably the 144. Because it's asking for the largest number.
All our questions must be different.
Yep. They usually are. Now sometimes you might luck up and get one that's the same, but not on the test, because I do so many things to the test that very rarely you're going to get the same thing. Okay, so it's looking for 24 then. If it's not looking for 144, then it's looking for 24. Okay, so when you're doing these questions, like I say, I'm not trying to circumvent the question. I just don't understand why they have to write it in a way that confuses the student, and these confuse. So that's why I don't use them on the test. And I tell you to take the two numbers and do the least common multiple and the greatest common divisor. Choose one. If it doesn't work, it's usually the other one. Yeah, it's the same. Yeah.
One of them I got like 5 million something.
All right, next one. Next one is number 19. So this one might have big numbers. Okay. This one is the problem that should not be in there. The number is 3, 5, and 217 or something like that. I can't remember. What are the three numbers? 3.
No, 3 numbers.
Is it 5, 7?
No, I think you have to put all of them.
No, it's 3 numbers. It's either 5, 7, or 3.
5, 30.
Okay, so it's 5.
It's our.
5.
17.
There you go.
517, 257.
Yeah, 5, 17, and all of them are prime, and 257. That problem should not even be in this homework. So that's the answer, and it's not going to change. So I'm glad you sent that question just so I could go over it and tell you the answer is 5, 7, and 257, and also tell you that it is not a test question, and it should not even be in the homework. So whoever picked that one to be in the homework, which is the lead instructor for this course, not me, whoever configured this, whoever configured MyLab Plus for 155 should take that one out because it's not even. Okay, so that takes care of our 2 questions sent. Anybody got any other questions? I think I've got all those. Hopefully, next time y'all send me some, I can find them. I don't know why they should be going to my folder, like right there. And for some reason they're not. I might have to get IT to look at it. But keep sending them, and hopefully I can find them. All right, let's look at the handy-dandy slideshow. Let's see, where did I don't know if I use this with y'all. Okay, this is fractions, and I told you I was going to go over the whole section today because I just hit addition and subtraction the other day. Now, I'm going to go over all the fractions and when to use them and how to convert them and all that good stuff. So, with this being said, rational numbers are all the numbers between whole numbers and all the decimals and percents. I'm not going to sit there. Real numbers is everything on the number line, including whole numbers, fractions, decimals, everything. Okay? And there's an example of rationals. Okay? There's the whole numbers, and there's the fractions. And negatives, of course. Negatives are what we call integers. Okay? And integers, we'll get into that later. That's 5.2. We'll get into that after we finish 5.3. You don't have to write all that down. Just write rational numbers or all numbers on the number line, whether it be negative, whether it be positive, whether it be fractions, decimals, whole numbers. Anything that you can locate on the number line is called a rational number. Now, I'm not going to insult your intelligence. You can write down what you want on this slide, but there are 3 examples of fractions. Those are all proper fractions. Proper fractions is the bottom heading. Okay? Just think of it as boxes. If you have the biggest box on the bottom and you put a smaller box on the top, is it going to tip over? No. The bigger box is going to hold up the smaller box. So that's proper. Those are proper fractions. Proper fractions are between 0 and 1. Write that down. Proper fractions are between 0 and 1. Or 0 and negative 1, depending on if they're positive or negative. Some of you that's familiar with a toolbox, it's the wrenches between 0 and 1. 1/4. Huh?
And 0 and negative 1.
Between 0 and negative 1. 0 and 1, 0 and negative 1. Or you could say between negative 1 and 1, if you wanted to. Okay? If you have a toolbox and you got wrenches in there, you got wrenches 1/4, 3/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16. All of those wrenches are between 0 and 1. Those are all all proper fractions. The numerator is on top, the denominator is on bottom. Again, you don't have to write that if you know that. I don't want to insult anybody's intelligence. But I will tell you that out of this whole book, this is the weakest section for students. Okay? So I'm trying to walk softly because I don't want to insult anybody's intelligence, but at the same time, this is where everybody's the weakest. Fractions. To reduce a fraction to its lower terms. I don't know what you're asking here. Okay. If I wanted to reduce a fraction to its lower terms, I would divide by 2 or 3 until I got it down to the smallest number I could get it down to. So in this case, I would divide both the top and the bottom by 2. You don't have to divide by 2. You could divide by 9 if you wanted to. But I'm going to divide by 2 because 2 is the easiest number to divide by other than 5 and 10. Okay? I'm not going to divide by 10 because 54, 10 won't go into 54. I'm not going to divide by 5 because 5 won't go into 54. Now, I could divide by 9. I will not get the wrong answer. But I'm not going to do that because 9 to some people is very difficult to divide by. So I want to divide by 2 because they're both even and 2 is an easy number to divide by. So 2 will go into 54 how many times? 27. That's right. So you're thinking 6 times 9. Okay, so I'm going to do 54 over 90. And I'm going to divide by 2 and divide by 2. What's 2 over 2? 1. So I'm only dividing by 1. So it don't matter. So that gives me 27 over what? 45. Now, knowing that what you know out of 5.1, you know that you can divide by 3 with both of these. Why can't you divide by 2? Because they're not even. 2 only goes into what? Even numbers, Hubert. That's right, class. So I'm going to divide by 3 on top and 3 on the bottom. Now, why am I dividing by 3 and not 9 again? Because 3 is easier because it's a smaller number. What's 27 divided by 3? 9. What's 45 divided by 3? Can I keep going? What am I going to divide by now? 3. 3 over what? And I am what? Why are you done? Because what is 3 and 5? Prime. Now, is that the only way? Is that the only way you can do in 5490 is down to 3/5? Yes or no? It's not the only way. You can do it however you want to. If you do everything correctly, will you get 3/5? Yes, you will. I did it the basic way. I did it the basic way to show people the most basic way you can do it and not have to remember too much. And that's what I do. I show people that way. I don't show people, oh, I already know what I'm doing. That don't work too well, especially with students that have a hard time with fractions. Okay? I divided by 2, then I divided by 3, then I divided by 3 again. And that's how you simplify or reduce a fraction. Capiche? Let's see what they did. They probably divided by 9 first thing. No, they divided by 18, which you can do that also. I don't teach. To me, if you use the greatest common divisor, that's fine. But what does it take? It takes a little bit too long to do that. So I tell students you can use the greatest common divisor, and that's fine and dandy. But who in here can divide by 2s real quick? I can. Okay? I can divide any number by 2 more expediently, or whatever the word is, or faster than I can do the greatest common divisor. So you use whatever you feel, whatever you're comfortable with. But I'm going to do it. If you come to my office 5 years from now and you say, Hubert, reduce this number, I'm going to divide by 2. First thing I'm going to do is divide by 2 or 3. One of those two. And I'm going to get it down to a number that's more what? Manageable. What's more manageable? 54 over 90 or 9 over 15? 9 over 15 is more manageable. So you do whatever you want to there. I'm not going to hold it against you if you use a different method. Mixed numbers. Okay, there's 2 examples of mixed numbers. You can write those down, but when is the only time you use mixed numbers? For units of what? Measure. Write that down. The only time you use mixed numbers is for units of measure. Or if the problem starts with a mixed number, you what? You end with a mixed number. That's a general rule of science and math. If you start with a decimal, you end with a decimal. If you start with a mixed number, you end with a mixed number. But most of the time, mixed numbers are used for units of measure. And a lot of people say, well, I thought it was, my teacher in high school told me that it was simplification. No, it is not. Does anybody in there see anything about simplifying an improper fraction to a mixed number? No. All right? And I'll show you. I'll prove it. I had a professor at Clemson. Did y'all notice when you watch the ball game, did they say Clemson? Or did they say Clemson?
Clemson.
Yeah, they go Clemson. Clemson. I did turn back and forth every now and then to see what the score was, but when it got to be 48-0 or 48-7, I kept watching the movie. Huh? But I did hear them say Clemson a couple of times, or they say Clemson. Because they don't want to say Clemson. If you say Clemson, like everybody around here says, you're one of the deplorables. So you don't want to say Clemson.
No Kirk Street trouble.
Then you're one of those. You're South Carolina redneck if you say Clemson. So the sophisticated announcers, they go out of their way not to say Clemson, and they say Clemson. Clemson.
Then you have Clemson. That's like.
So anyway, it's just one of those words that when you say it, it sounds like it has a P in it. And people go out of their way to not pronounce the P because they don't want to be associated with us deplorables, South Carolinians. Kind of like the word OIL. Some people will not say OIL because they think they're saying it wrong. Or COIL or FOIL. Because you always got one in the group that says, oh, I don't understand what you're saying. Whatever, shut up. Anyway, let's go with 3 over 5. 3 over 5, I'm sorry, that's wrong. That's a problem.
I was going to say that's not a mixed number.
Oh, I might as well just quit. 5 over 3. 5 over 3 is what we call a what? Improper fraction. And a lot of teachers have told you in the past, don't change that to, don't leave it as an improper fraction because it's not simplified. Yes, it is. Because the definition of simplification in a lot of math, especially basic math, fractions, decimals, and percent, is how many times your pencil hits the paper. So how many times does your pencil hit the paper when you write 5/3? 1, 2, 3. 3 times. Everybody with me? So what is it when it's a mixed number? Well, 3 will go into 5 one time, and 3 from 5 is what? 2, and then 3. So how many times 1, 2, 3, 4. So 3 times here, 4 times here. So which one's the most simple? The improper fraction. The improper fraction is simplest form. Then why do teachers tell you to change it to a mixed number and say a simpler form? Because they are incorrect. Okay? The only reason you use mixed number is because the question either starts with a unit of measurement or it's asking you for a unit of measurement. For example, Jane has 2 3/4 cups of flour, and Sam has 1 1/4 cup of flour. If they add them together, what do they have? The whole point is the question has started with what? 1, a unit of measurement, a cup, and then 2, that started with mixed numbers. So if it's a unit of measurement or the question starts with mixed numbers, either one or both, then you're going to end with a mixed number or a unit of measurement. Some people don't know that. Some people think that if you change to a mixed number, that's the simplest form. Nope, it is not. There's your impropers. Improper. If you have a small box and you put a bigger box on top of the small box, what usually is going to happen? It's going to tip over. That's why it's called improper. Improper fraction is top heavy. There is an improper fraction, 8/5. Think of it as boxes. You got a big box on top of a small box. And what usually happens when you, like on a shelf, if you take a small box like this and you put a big box like this on top of it, it's going to fall over. You don't have to write down all that. Just write down improper fraction equals 8/5. Because I think 99% of you probably know what a proper and an improper and a mixed number is. I don't want to insult anybody's intelligence. Okay, let's see if everybody can change this number into an improper fraction. I'm not going to ask you to answer the question. I'm just going to throw it out there and say, can you change it? And then if not, I'm going to show you how to. And if you do know how to change it, then good. So you want to change that to an improper fraction. So just remember the big C. The big what? The big C. Just do this. Draw a C and add a little. Well, today this pen just does not want to work. There. And add a little symbol right there like a plus sign. Thing is just not working. I know what it is. I need a battery. But every time I think about it, I forget. There we go. What is 2 times 5? So I'm going to write this 2 times 5 3 over the denominator. So 2 times 5 is 10. 10 plus 3 is 13. So 13 over 5. How do you change it back into a mix? You divide. You divide. Five into 13. 5 will go into 13 2 times. And then 2 times 5 is what? 10. What's 10 from 13? 3. And you bring down the denominator. So, again, most of you know how to do that. I don't want to go into it very much because all of you should know how to do that. What is 8 times 4? 32 plus 7? 39 over 8. How many times will 5 go into 8? One time. What's left over when you say 8 minus 5? 3, and you put that over the denominator. They must have that. They must have that microphone turned all the way up there. We can hear everything y'all are doing up there.
Oh, that's wrong.
Can y'all hear everything we're doing, or is it just kind of quiet?
Pretty quiet.
Yeah. All right. So how many times will 8 go into 22? 2. 2 times 8 is what? So what is 22 minus 16? So what, 65? How many times will 8 go into 65? 8 times. And that's 64 with 1 left over. So that is 28 1/8. Let's check it. 8 will go into 22 2 times. 2 times 8 is 16. That leaves us 6. Bring the 5 down. That's where I got the 65. 8 will go into 65 8 times. 64, and there's your 1 remainder. Now, y'all notice I do a lot of the long division in my head. Should y'all be doing that after 12 years of high school? Yes. You should be able to do that. Do you?
No.
Not a lot of people do.
I think it's because they use calculators and tell us to run on it. So it kind of,
Yep.
even our
That's sad. That's really sad. Have you ever watched, one of my favorite things in all the world is trivia. Okay? And I love to watch Jeopardy.
Oh,
And I will record it and watch it because I can't stand the commercials. So I will watch Jeopardy, and there's a team tournament, and then there's a teacher tournament. Well, they had a teacher tournament. It was like earlier in the year, and they just ran recordings of it because I guess they're on vacation. And guess what subject they stayed away from? Math. Now, is that a funny thing or is that a sad thing? It's
That was
sad
sad.
that you got teachers at a teacher's tournament and the last category on the board is math because they didn't want to go to it. That's sad. Damn Russians. What?
I like.
I do not like the Wheel of Fortune. I cannot stand the Wheel of
And the
Fortune.
one with Steve Harvey, what's it called?
I don't watch it. The only game show I watch is Jeopardy, and I record it. And I love to play Jeopardy's, when they have trivia at the bars, I love to do that. Thanks for karaoke. I love karaoke and trivia. All right, so here is repeating decimals. Okay? And y'all learned this back in the, third, fourth grade? That if a number is repeating, you just put a line over it. Now, I'm not going to go into that with you, but I'm going to show you how to make a repeating number out of a fraction. Okay? Because not a lot of people know how to do that. But these are repeating. I'm not going to go into this. Y'all should know that 0.3 is 0.3333, and 0.2323 with a line over the 23 means that the 23 is repeating. Okay, so that's not a test question. However, this is a test question. Show that the following rational number can be expressed as terminating decimal. Okay? Now, the first thing you're going to do is you're going to, hold on a minute. That's not
Tell us the answer. Sweet.
Hold on a minute. These you just divide. 5 will go into 4 0 times. You add a 0. You add a 0 and a decimal. Okay, I'm not going into those. That's not the one I'm talking about. Hold on. These are repeating. And you'll see that on your calculator. These you can do on your calculator. There, here we go. This is where we turn. Okay. This right here, it says convert 12.142, and that's a repeating decimal, to a quotient of integers. Now what we're going to do here is we're going to say x is equal to 12.142, and then we're going to multiply it by 100. You'll see why in just a minute. Okay? Or 10. In this case, probably going to multiply by 100 or 1,000. There we go. N is equal to 12.142. The first thing you do is you set N equal to this. Okay? N equal to this. Or X. If you want to use X, knock yourself out. I don't care. You can use Q if you want to. Now I'm going to multiply. I would multiply by 100. That's what I would multiply by. That's what they did. Now, why do they multiply by 100? Because they want the repeating decimal to be by itself. Do you see where it's by itself now? It doesn't have the 1-4 in front of it. It has a decimal in front of it now. You see what you see there? Okay? Now, why do you do that? Because you're going to subtract it. And that's the next step. You're going to subtract 100 minus n, which will be 99. Why did they do that? Why didn't they just multiply by 1,000? Hold on a minute. Okay, they multiplied by that. That was about the dumbest thing I think I've ever seen. Okay, just ignore it. Instead of multiplying by 100, you multiply by 1,000. Okay, don't just ignore this. I don't even know why they did that. Sometimes they do some kind of stupid stuff. So let's just mark through this. Let's mark through that and mark through this. And 1,000n, what's 1,000n divided or subtracted by 1n? 999n. And then you're going to, or they're going to subtract it from the 100. They might subtract, that might be how they did it. Let me go back. Wait, hold on. There. They're going to subtract 1,000 from the 100 from the 1,000. Yep, that's what they're doing. They're doing it that way. There's two different ways you can do it. You could subtract the 100 from the 1, or you could subtract the 100 from the 1,000. Now, why are they doing this? Because what happens on the right-hand side when you subtract those two BA numbers? What happens to the repeating decimal? What happens to the repeating decimal? It cancels. And that's what you're doing. You're trying to get rid of the repeating decimal. So you multiply, in this case, you'd multiply by 100, and then you'd multiply by 1,000. And then you subtract those two from each other. And what is 1,000 minus 100? 900n is equal to, somebody take your handy dandy calculator and take 12,142 minus 12,14. What do you get? $12,142 minus 12,14. I'm sorry, say again?
10,928.
Now divide by 900. What do you get? 1.142,222?
Yeah.
Okay, this is your fraction, because when you get this fraction, if you divide it, you get what you started with, 12 0.142 repeating. So here is your answer. Now you could reduce that. So take a minute and reduce it. Divide by 2's, divide by whatever you need to divide by. But that is the answer.
So we don't have to reduce it.
Yeah, you need to reduce it.
Okay.
Go ahead and reduce it. The reducing, I mean, the mathematical fraction is equivalent. So if I'm going to divide by 200 or by 2, I get 5, let's see, 2, 4, 6, 4 over 450. And then if I want to divide that by 2, I get 2, 7, 3, 2 divided by 225. And I can't divide that by 2. The only thing I divide by is 5, and that top one is not divisible by 5. So the only thing I can't divide it by 7, 11, no, because 11 won't go into 225. 13 maybe, I don't know. Let's see what they come out with and see if they get 2732. They might be divisible by 13, I don't know. 2732 over 225, that's it. Don't worry, somebody's going to send me this in homework, so we're going to see it again. Okay? Now, why did you multiply by 100? You multiplied by 100 to get this repeating decimal by its what? By itself. Now, the reason they repeated, they did it by 1,000 again, multiply by 10, is they need another number to get the variable what? I mean, to get the repeating decimal by itself again. So you subtract the 2, you basically cancel out the what? The repeating numbers. That's why you do that. I was going to do it with, but see, it's not by itself. It's got the 0.14 in front of it. So that's why you had to multiply it by 1,000. It took me a minute to see that. And like I said, this is a test question, but it's only one test question. I don't put more than one of these on the test. So write it down in your notes, but you will see it again because somebody's going to send it to me in the homework. Multiplication of fractions. Let me check the time before y'all explode. Oh gosh, my dadgum wrecked TV man's going to be at my house at 12. I hope he hasn't called me yet. So.
Yeah, we got the channels back. Did you notice that?
What?
Like, we didn't have CBS and like a whole bunch of channels. We got back.
I don't watch CBS, so I didn't know they were even.
I watch Big Brother stuff.
Yeah, I don't watch a lot of. I watch a lot of Fire Stick, Hulu, Netflix.
Yeah, we have Netflix. Hulu.
Yeah, I don't watch a lot of the. Because for one, I watch Jeopardy, but I record it so I can.
Yeah, we don't
I'm
watch.
too cheap to pay for cable.
Yeah, I don't watch commercials. That's one of the reasons
I watch
TV is because of commercials.
Or used to.
Now, I do like some commercials. I like some commercials. That emu, that gets on my nerves. That commercial gets on my freaking nerves.
Oh my gosh.
Some insurance company with a emu running around with some weird guy. He's creepy.
It's Liberty Mutual.
Yeah, that's Liberty.
Yeah, it's annoying. And then that guy that talks about your retirement, and he's got this big old beard and these glasses, and he says, "Kale's too much work." Oh God, he's annoying.
My favorite's the State Farm.
I love State Farm. Yeah, I love State Farm. State Farm is funny. I think Progressive is funny. Some of the Geico commercials are funny. I love the camel. Hump Day. I wish they'd bring him back and burn that little box, that talking box. God, he's annoying. It's amazing how some commercials just annoy the crap out of you. Y'all have an annoying commercial?
Have you seen the new Hardee's commercial? it's kind of like making fun of vegetarians, I think.
Oh my.
Because it's talking about their new burger or something.
Oh yeah, and save from
Save
vegetables.
plants. It's like no plants were harmed in the
Yeah.
making of this burger.
That's hilarious. I love it.
That was so funny.
The annoying commercial on the radio is the Cars for Kids. Oh my gosh, I turn that off every time I hear it. Oh my
I
gosh. What?
swear.
On the State Farm or
I
whatever.
can't even keep it right
You know.
I hit the animal adoption one.
I don't listen to radio a lot.
Yes.
No, I listen to my
It's like
Spotify.
strapping the truck form of easy.
And it's not even Christmas.
So y'all have another annoying commercial?
I'm Jay Gilstrap, Gilstrap Family Dealership. The truck
No.
is easy.
I don't hear that one.
God.
I listen to XM, so I don't hear it a lot.
Oh,
But I hear that stupid
I literally, like, every time I pass by the platform, I want to stop and slap him in the face.
I
Make
will
your voice
turn my
sound-
radio off when that comes on.
It comes
And I'm
on
gonna ask you
every
something. All the
second.
homeless people we got in America, why do we have commercials for like 30-minute commercials on dogs and cats?
Like, I just, so funny. God. So depressing.
Okay. All right, multiplication. Here we go. Multiplication. There's two ways to do it. And I got to stop after this because it's, what time's class over?
12:10.
Okay, it's 12:10 now. Let's just pick up multiplying when y'all come back.
We don't come
wanna
back
go
till
all day.
Wednesday.